Great, so we're getting into our kind of proofs with this lesson and then lesson 5. So today we're going to be talking about some things called Lewis Carroll logic puzzles, which is the more informal type stuff. And then we're going to introduce algebraic proofs, which you guys have probably seen before. And then next time is where we really kind of see how proofs work in geometry, the more geometric proofs. We're going to be talking about that next time. If you take a look at the assignment guide, or if you've noticed in the past, I do not have a quiz for this lesson or lesson 5, because proofs are just really hard and complicated to create. So to compensate for that, there's a couple more proofs on the test, as opposed to having quizzes on this. But what we're going to talk about here in lesson 4, the Lewis Carroll logic puzzles, I am not going to be assessing you on that. It's going to be a bonus question on the quiz. This is more just like an honors extension kind of brain teaser, kind of high level thinking type thing. So that's where we're going to be spending some time on this. We're not going to do all of them. Let's see, I think I crossed out a few. Yeah, we're going to be just doing a couple of them to kind of let it sink in. And then we're going to talk about the algebraic proofs at the end of this. So what we're going to talk about, the Lewis Carroll logic puzzles, are not going to be assessed officially, but there's a bonus question on the test just on this. Great. So have you guys ever heard of Lewis Carroll before? He's an author. I believe he wrote Alice in Wonderland, maybe. He writes kind of like weird, kind of whimsical type stuff, so it makes sense that he would write these kinds of things. So he has logic puzzles to actually use the law of syllogism to help us understand. The reason why they're called logic puzzles is because they make no sense necessarily, but they're still logically logical. If you look at like one of these, we're talking about saucepans and tins and presents and stuff. Really, like, why are you talking about that? It's kind of nonsense. But when we look at it with a syllogism, it logically makes sense the way that the argument flows. So, and the way that you can reach a conclusion. So that they're kind of silly, but they're still using the law of syllogism, so they're meaningful. So the way that we use this is we look at syllogisms, we look at rearrangements, which means sometimes the steps of the syllogism are out of order, so we have to rearrange lines so it's in the correct order. And then sometimes we also have to use equivalent statements. Do you guys remember what's equivalent to a conditional? Contrapositive. So underneath equivalent statement, I want you to write contrapositives. You remind yourself. So we use syllogism, rearrangements, and contrapositives, or the equivalent to the conditionals, to figure out what a logical conclusion should be based on the argument. So instead of jumping right into the Lewis Carroll logic puzzles, which are all words, I'm going to show you how this works with symbols, because that's the problem. We're going to take this, turn it into symbols, and then kind of rearrange it to see what the conclusion would be. I'm going to do that here just in symbols to set our foundation. So this first box right here is already set up. So here it goes PQ, QR, RS. You see how that's set up as a syllogism? When it makes that zigzag shape, that's what you want to have happen for it to be a logical conclusion. So see how I circled the P and the S? What do you think my conclusion would be? P to S. So this is the way that our logic puzzles are going to work. We need to arrange them in a logical format for the syllogism, then we link the beginning and the end. Now I don't have this written in, so you guys have to write it by hand. You want to look for 2 unique ideas. That means it's the letters that only show up once each. So P only shows up once and S only shows up once. Those 2 unique ideas, those are your beginning and your end of your syllogism. They may change as you're rearranging stuff. They may change signs, so don't just assume whatever you see written is the conclusion. But those 2 unique ideas are going to be linked together somehow to create your conclusion from the syllogism. So write down, look for your 2 unique ideas. They're going to be the beginning and the end. And technically you get to choose which one you want to be the start, which one's the end. Doesn't really matter. So this is one where it's already set up nice for you. This is what you want it to look like, that zigzag kind of shape. Now this one's not like that. This one's kind of jumbled up. You don't have everything in a true zigzag fashion like it should look for the syllogism. And also I'm introducing something new here. I have P written twice, but this is a special case, and I want you to write this too. If you have a singular idea, so this is not a conditional statement. If it's just one letter, it's a singular idea, that's always going to be the beginning of your argument. So if you have your true syllogism, look for the unique ideas. But over here, if you have a singular idea, that will always start. So that's like an extra little special case. So P is going to start, but what is the other letter in here that only shows up once? X. So P is going to be our beginning, and then we're going to end with some form of X. We don't know if it's going to be X. It could change to not X if we use a contrapositive. So you don't want to just assume it's P to X. You got to be really, really careful. All right, this is all jumbled up. I know that P has to start. So P was in the wrong position, so I'm going to have to rewrite this. P was at the end. That's not supposed to be what's happening. So I'm going to put P at the beginning. But for a syllogism, if I start with P, what should my next line start with? I didn't go P to anything, so my next line should still start with P. So do you see any lines in here that start with P? Okay, so that means that line has to come next. So cool, this one. What I like to do with logic puzzles is cross out the lines as you're going. So I already used P, so cross it out. I already used this one, so now cross that out. Cross out the lines as we use them, so you don't accidentally use them again. Alright, so I started with P, then I went P to not Q. Do I have any sentences or lines in this structure that starts with not Q? The top one. Alright, so that's going to come next. Oops. No. Go. I accidentally gave it away. Just get the box back. Where did it go? There it is. Well, okay, give me 1 second. I'll get that one way too early. Alright, so now you can cross out that line because I don't want it anymore. Now, do I have any lines that start with T? Okay. Now this is where this comes in. This line right here, the only one we have left, says X arrow squiggle T. But that's not the correct structure to continue my zigzag shape. So how could I change that, keep the same truth value, but make it so that T is in the front?
T, school.
Okay, what do you call that? It's contrapositive. That's why I had you guys write contrapositive up here. So I can take this statement and I can write the contrapositive instead in order to get the T to show up on the left-hand side instead of the right-hand side. See how I did that? I didn't change the truth value, right? Because the contrapositive is the same truth value as the original. So I didn't change or mess up anything. I just rewrote it in the format I need for the syllogism. So do you guys see that cascading kind of pattern for the syllogism? It starts with what the previous line ended with. So now once you have it written correctly, what's my conclusion? Yep. P arrow. So you take the first idea and the last idea and you link them together. This is really how we approach our logic puzzles. We have to shift the lines around and then use a contrapositive a couple times maybe, so you get the cascading zigzag torque. Right? Sure.
What if, like, we were trying to find T, but, like, it was X to, like, T, but still T, probably just...
So they would, if they had that, then you'd have to say there is no conclusion. Because if you can't use a contrapositive to get it to the correct sign that you need, then there's no conclusion. So there is a possibility we're going to see that in here. Alright, so in here, I don't have any singular ideas. They're all if-then statements. I already circled them, but what are the two ideas that only show up once? The P and the squiggle X, or the X term. So those are the ones that only show up once, so those are going to be our start and our end. The best way to do this is to start with the one that's positive. Start with the one, you can technically still start with squiggle X, but it usually works better to start with a positive one. So I'm going to start with the line P to Q. Once you use that, cross it out so you don't accidentally use it. So cross it out. Alright, looking through this, do you have any lines that start with Q? Because I need the next line to start with Q. No, but are there any that you could write the contrapositive so that it does? The second up from the end, see the K arrow squiggle Q? Can you write the contrapositive of that? What would it be? It would be Q arrow squiggle K. So I can take the second line from the bottom, write the contrapositive, and then cross it out so you don't want to use it again. Are there any lines that start with squiggle K? Are there any lines I could use the contrapositive so that it does start with squiggle K? The very, very top, the T arrow K, I can take that one and write the contrapositive so it becomes squiggle K arrow squiggle T. So use the contrapositive and then cross it out. Are there any lines that start with squiggle K? Sorry, squiggle T. No, that. Okay, squiggle T to W, the one at the bottom. Any lines that start with W? The fourth one down, one kind of in the middle there. Any that start with Y? Any that I can manipulate so that it does start with Y? I can use the contrapositive of the second statement. That would get me Y goes to X. So what would my conclusion be? P X. Everybody see how we do that? We shuffle the steps around, use a contrapositive here or there. And like Carmen was bringing up, if you can't use a contrapositive to get the sign to work correctly, that just means that the structure is not going to have a logical conclusion. So you just say, can't find a conclusion. So that's what we're trying to do. We're trying to find the conclusion. You can't get the zigzag shape to work with the correct signs, just say no conclusion. Okay? Now let's take a look at the actual Lewis Carroll, because that was with the symbols. The Lewis Carroll logic puzzles start with words, right? And this is back when they were using like these and thous and stuff. So the wording is a little bit weird. So we have to be really, really careful, because we're going to take the words and turn them into conditional statement symbols, and then do the shuffling and stuff. So it's an extra step of converting the symbols first, and then doing the manipulation we're doing above. So to start, go ahead and underline the word only in the first statement, and then the word none in the last statement. You want to look for no's, nones, and only. Those words kind of indicate how we're going to work with the structure for the symbols. So the first sentence says, my saucepans are the only things I have that are made of tin. When we're writing the symbols, we're going to use letters that match, variables that match the situation. So we're talking about saucepans, so what letter might we use? And then we're talking about things that are made of tin, T. So what do you think the symbols would be? You might think that it's S-arrow-T, but that's actually wrong. It should be T-arrow-S. Can anybody explain why? It should be if it's made of tin, then it's a saucepan. That's essentially how you would rewrite that as a conditional. Why did I switch the order? Does anybody think they can explain why you would write it the other way around? Or what you would normally expect? Have a visual. John, this is your kitchen. Okay, maybe that's how you draw a saucepan, I don't know. So it's saying that my saucepans are the only things that I have that are made of tin. So in the tin category, I should only have saucepans. Yes? But does that mean that I can't have a saucepan that's not tin? Can I also have a saucepan that's pewter, which is stoneware? Yeah? Okay. So if you were to say that if it's a saucepan, then it's made of tin, that wouldn't be true, because what if I'm talking about this saucepan? It's made of stoneware. Okay? So the way that you represent this visually, it helps you understand that if it's made of tin, if you're narrowing it down to tin, which is what the only does, the only is narrowing it down to this idea here. If it's tin, then it has to be what? A saucepan. It can't be anything else. So when you guys see the word only, whatever follows the only better come first. Okay? So for that statement where it says, my saucepans are the only things that I have that are made of tin, right? You would say, let's see if that pen will work. If it's made of tin, then it's a saucepan. T-R-O-S. Question? Great. So the next statement says, I find all your presents to be very useful. How could I say that as a conditional? Well, let's say the words like if, what, then what?
If it's one of your presents, then it's very useful.
Yeah. If it's one of your presents, then it's very useful. So how would I represent that? P, arrow. I use U for useful. P for present, U for useful. It's really going to be confusing if you try to just use your P and Q. So if you don't know what the variable is referring to, you can't kind of manipulate it at the end to figure out what your conclusion is. So use letters that match the sentence. Okay? Then the last, we talked about this on day 1. If the word none shows up, do you guys remember what you do? It says none of my saucepans are of use. It is a negation, but what happens when you write the order of the conditional? It goes at the end. Remember we talked about it on day 1. If you see the word no or none at the front, this idea goes at the end. So if you were going to say it as a conditional, you'd have to say, if it is of use, then it's not a saucepan. We talked about that on day 1. If it starts with none or no, these ideas swap. So if it is of use, then it's not a saucepan. Again, if it starts with no or none, it swaps the order. Alright, so this is what the argument looks like at first. So now we have it kind of look like our examples above. Now we got to shuffle stuff around so that makes sense. I circled the T and the P because those are my two unique ideas. Remember, if something only shows up once, it's going to be your start or your end. Now, they're both positive, so you get to pick which one you want to start with. Well, since I already typed stuff in, I started with P. Or no, I did start with T. You're right. But again, you can choose whichever one you want, but in this example, we're going to start with T. So I'm going to start with T arrow S. I'm going to start with that line. What should my next line start with? S. Do I have any lines that start with S? But can I get a line to start with S? Using contrapositive. I can take the third statement, and I can switch it around using the contrapositive, and that would give me S arrow squiggle U, if I write the contrapositive of the third step. And then do I have any statements that start with squiggle U? So that's what my next line needs to start with. Can I get a line to start with squiggle U? Which statement? It's the only one that's left, right? The second one. Can I write the contrapositive of this and get the squiggle U to come to the front? Yes. So if I write the contrapositive of the second line, I would get squiggle U arrow squiggle P. So I have a true syllogism lineup. So then what would my conclusion be? If T, then squiggle P. Now this is the Lewis Carroll way of saying it. He didn't write it as a conditional statement, right? If you were to say it as a conditional statement, how would it go?
If it's made of 10, then it's not.
Yes. If it is made of 10, then it's not one of your presents. I'm fine with you writing it as a conditional. If it's made of 10, then it's not one of your presents. You just use the none structure, and none of your presents are made of 10. It's the same idea. You just wrote it without the conditional. And I'm fine with either from you guys. Okay? You see how we did that? Convert to symbols and then shuffle stuff around. Yes.
For the ones that like they didn't say then, but you still put this arrow, how do you know?
You need to always how to not use an arrow.
Oh no, like sometimes if it didn't say if or then you don't use it. Is it always?
You can always turn a statement into an if then statement. You just have to be really careful on how you do that. Other questions on this first one? Alright, let's try the second one. Jenkins. The Jenkins example. So go ahead and underline the things I've underlined. Underline the word no, and then the little in for incompetent, and then underline the word no in the last statement. A good idea is to read through the entire thing first to get a kind of grasp of what's going on here. So it says no experienced person is incompetent. Jenkins is always blundering, and then no competent person is always blundering. Okay? So we're going to figure out what's going on with the conclusion here. Now, I underlined the word in for incompetent because I see competent show up again. And so I'm going to have to make a connection between those two words. So hold that thought in just a second. What does no do when it's at the beginning? It switches the ideas, right? So how do you think I would write this statement as a conditional? Squiggle P? Squiggle E, maybe for experience? So that's what I thought. When I was making the answer key, that's what I had thought too. I chose I for incompetent, and then I wrote squiggle E for not experienced. But I'm actually going to write squiggle C for not competent, and I'll explain why at the end. But I'm going to use squiggle C instead of I, so not competent, and then not experienced at the end.
Wait, so like the squiggle part, did it matter like which thing? I mean like which side though?
Yes. So because the no starts at the beginning, it automatically takes the not experienced idea and puts it at the end.
But like does it fit in no?
You only change the order if the no is at the beginning.
Oh.
If you see no anywhere else in the sentence, it's fine where it is. It's just where you see no or none at the very, very beginning. Great. How would I rewrite Jenkins is always blundering as a conditional? If it's Jenkins, then he's blundering. So how would I write that in symbols? J arrow B. If it's Jenkins, and he's always blundering. Okay. And then I have the no competent person is always blundering. So remember, when the no or none is at the very beginning, I take the two ideas and I swap them. So then what would come first? B for blundering and arrow and then squiggle C. Now the reason why I chose squiggle C for the top for incompetent is because if I introduce an I, if I use I, then I would have I, E, and J would all show up only once. And you can only have 2 letters that show up once. So if I didn't use I went back and I changed it. Since I had competent already, I just changed this to squiggle C as well to stand for your not competent idea. You can't have 3 unique variables, you just need 2. So that's a little bit of kind of odd manipulation you may need to do. Like in the one down here that we're not going to do where it says thin and fat, you have to say that fat is not thin. So there are sometimes manipulations where you have to make it a variation of a previous variable instead of creating one that's new. But we're not going to do that one. This is a little bit too complicated. Alright, so this is all jumbled up, not in the right order. Okay. Which one do you want to start with? Okay, J. Let's start with J. That's how I start. Alright, so we're going to start with J arrow B, because J is positive. What do I need my next line to start with? Do I have a line that starts with B? I do. That one comes next. What do I need my next line to start with? Squiggle C. Do I have a line that starts with squiggle C? Yes, I do. Cool. So they were all fine, they were just in the wrong order. So now that they're in the right order, what's my first idea and what's my last idea for the conclusion? Yeah, so you could say Jenkins is not experienced. That would be the kind of non-conditional. But if you want to write it as a conditional, you would say if it's Jenkins, then he's not experienced. Either way is fine. Yes.
Do we have to write in words?
Yes. Your answer needs to be a worded conclusion. We're using the symbols as kind of a middleman process of finding out what it is, but your final answer should be a worded conclusion.
And you don't care if it's like the first.
I don't care if it's the non-conditional versus the conditional. One or the other. Or both if you're wanting to be extra. Alright. Everybody okay-ish with the first 2? Alright, let's take a look at this next one. No ducks waltz. No officers ever waltz. All my poultry are ducks. We're going to find the conclusion. Alright, remember when no is at the very, very front, what do? Switch the order. So instead of writing no ducks waltz, you could say if they waltz, then they're not ducks. How would I write that in symbols? W arrow squiggle D for not ducks. My next statement says no officers ever waltz. So you could say if they waltz, then they're not officers. Then you have another W arrow squiggle O for not officer. And then the last statement says all my poultry are ducks. If it's poultry, then it's a duck. So then how would I write that in symbols? P arrow D, P for poultry, D for ducks. Alright, let's go ahead and rearrange this as best as we can. So the 2 ideas that show up only once, P only shows up once, and squiggle O only shows up once, so those are going to be the beginning and end. I'm going to start with the one that's positive, so I'm going to start with P. That line, I'm going to go P to D. I'm not going to use that line again, so you can cross it out if that's helpful. Alright, do I have any lines that start with D? Can I make one start with D? Okay, can I use the contrapositive of any of them? The first line? So I can find the contrapositive of the first line is going to be D squiggle, not W. Sorry, D arrow, not W. So my next line would need to start with what? It would need to start with squiggle W. The only line I have left starts with positive W. Can I use the contrapositive to get it to be a squiggle W? No? What's the only way I could get it to be a squiggle W? Is inverse going to be the same truth value as the conditional? No. So when you rewrite the order, it has to stay like that, but is that a true syllogism? No. So for this kind of situation, which Carmen was kind of foreshadowing for us, you would get no conclusion. If you cannot get the symbols to line up correctly using your contrapositive, then no conclusion. You cannot use inverse or converse, because those do not maintain the truth value. Alright. Just a couple more. Alright, this is one that I made up, so it's not, I have it mostly in if-then structure, so it's a little bit easier to understand. If an animal has horns, it won't kick. Symbols.
H.
We're gonna use H for horns.
Okay.
Okay, so it should be has horns, then it doesn't kick. Or won't kick. So H, squiggle K. Animals that don't kick are nice. So if animals don't kick, then they're nice. So it would be squiggle K, arrow N for nice. If an animal has no horns, it's not a donkey. Arrow. Okay, squiggle H, arrow, squiggle D. And then I'm a donkey. It's just D. That's not a conditional statement, right? There are not two ideas, right? When you have two ideas, you can write that as a conditional statement. If there's only one idea, you can't really, there's no if or then, it's just one idea. So that's just going to be D. So if you look through your letters, what are the two letters that only show up once? Well, excluding the fact that this D is singular, so this one has to start. Remember, that's our exception. If it's a singular letter, that has to start. But what's the only other letter that shows up once? N. So it's going to end with some form of N. Whether it's positive or the negation, we don't know yet. All right, so if my first line has to be the singularity, a D, what should my next line start with? Should also start with D. Do we have any lines that start with D? Start with D? No? Can we make it so it does? Which one would I use the contrapositive? The third line down, if I use the contrapositive, I get D arrow H. Do I have any that start with H? So I have H, squiggle K. Do I have any that start with squiggle K?
Yes.
Alright. So then what would my conclusion be? D arrow N, which if you turn that into words would be donkeys are nice, or if you are a donkey, you're nice. Yes? Okay. On the next page, you guys are doing those two on your own. So for these two, I need you to turn them into symbols, rearrange them as needed, and then find the conclusion. So go ahead and do that on your own. So you can't do that because you can put it back on the inverse, but the inverse doesn't do that. So they're opposite sides. And the other side doesn't have Alright, what conclusions did you guys get for this first one? Yeah, you guys should get, if you're by the water, then you're east of the ridge. Did everybody get that? There's a W arrow E for east. Yeah? And then what happened for the next one? You should end up with no conclusion, because when you guys are writing the layout, I believe you get cycle and can't cycle, and there's no way that you can change or use a contrapositive to get them to line up. So that one would be no conclusion. Alright, any questions on those? Okay. Now we're going to move on to the stuff that is really our foundation for the geometric proofs that we're going to do next time. These are algebraic proofs. I'm sure you guys have seen these before in Algebra 1, where they show you lines of the solving process. Like, here's an equation, and we go step by step. Tell me how we go from the first step to the second step, and blah, 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 blah. So I think you've probably seen this before, but we're going to practice it again, because this is a good foundation for how you set up proofs. So here's a little chart about all the different properties you guys could be using to solve. So the addition property, basically when you add something to both sides of an equation. So for example, if you had started here and then you went here, what did you do? You added 7 on both sides. You added 7 to get this to cancel, and then moved it over here to get 22. So anytime you're adding something, whether it's a number or a variable or an entire expression, it's called the addition property. So if we do abbreviate, but not too much, if you want to do like add prop, that's fine, but don't get into the habit of abbreviating too much when you guys are working with proofs. And yes, you do need to remember all of the theorem names and the property names and all that, because when you're writing out proofs, you have to state the reason of why you're doing something. So it takes a lot of remembering what all the properties are called. So adding the same thing to both sides is called the addition property. Subtracting the same thing from both sides is the subtraction property. Multiplying the same thing on both sides is the multiplication property. And dividing the same thing on both sides is called the division property. Yes?
Are you allowed to go like a?
Nope. Nope. I don't know why your algebra 1 teachers had to do that. In geometry honors, you need to spell it out. You can't just use letters. The only abbreviation you can do is just like add prop. But I would prefer you write the entire thing, addition property. Okay? So we have the addition property, subtraction property, multiplication property, and division property. Does that make sense? Like what all those mean? Adding, subtracting, dividing, or multiplying, same thing on both sides. Yes? Okay. You guys know the associative property, right? So we have 3 things that are being added or subtracted, and you have parentheses around 2 of them, and you can shift them around the other 2. Yes? Okay. You have the commutative property, which is when you're adding or multiplying 2 things, and you can switch the order. A equals B equals B equals A, or A times B equals B times A. It's just an operation where you switch the order. They're still going to be the same. Distributive property, we use it all the time. You multiply something through a set of parentheses. These reflexive and symmetric properties are easy to confuse. The reflexive property is when something is identical to itself. So like 4 is equal to 4, or X is equal to X, or segment AB is equal to segment AB. When it's equal to itself, it's a reflexive. The symmetric property is when you say that 2 different things are equal to each other, and you just swap the order of how it's presented on either side of the equal sign. So like A equals B is the same thing as B equals A. It's kind of like a commutative property, but without an operation. There's an equal sign in between them. So there's a difference between those 2. Transitive property is kind of like our syllogism. Transitive is when you have A equals B, B equals C, therefore A equals C. It's like our syllogism. P to Q, Q to R, therefore P to R. This is just the numeric version with equal signs. And then the substitution property is when you guys know what something's equal to. Like in this example, we have 15y minus 7x equals 15. If I know what x is equal to, instead of writing x, I can plug the 4 in. So that's substitution. When you know something, what something's equal to, you can substitute it into an expression that has that object. Typically variables, sometimes lengths of segments, stuff like that. So not only do you need these for the algebraic proofs we're about to see, you also need them for the geometric proofs. So make sure that you keep them in mind as we move forward. Here are some examples of algebraic proofs on the next page. We're just going to explain how we go from one step to the next. The first step for a proof is always really easy. They're going to give you this right here, and then the reason why that exists is because it's given. So the first line is always really easy. The first reason is always a given, every single time, no matter what the proof is. So I am given this equation. How do I go from step 1 to step 2? Distributive property. Then from step 2 to step 3, what did I do? Okay, so you can, that's not a specific property, you can just say combine their terms. And then from step 3 to step 4, it's the addition property. What did I add to both sides? 2. So I did 2 to both sides with the addition property. And then what reason supports number 5? How did I get to step number 5? The division property. Divided both sides by 12. So that's how you fill out an algebraic proof. Make sense? Okay, I'm sure that's pretty familiar, so I'm sure you guys can do the next 2 on your own. Let's go ahead and do example 2 and example 3, and then I'll move the boxes away so you can see if you did it right.
How's that?
Yeah, number 4 here was a mistake. I copy pasted it from a different thing. I guess I didn't check over it. That's supposed to say 3. It is an error. Sorry. Just say, step number 4 should say x equals 3. Once you finish, just glance at the board, make sure you have all the steps right. Now we have loads and loads and loads of time left to pass. So if you want to work on the homework, work on the graded assignment, get a jump start on the review, you work for another class, whatever, it's okay. You can have your phone out, but only if you will be listening to music, please. Let me know if you guys have any questions.